Howdy folks, welcome to the third episode of Full Stack Java Development with Docker. In previous episodes, we saw how to create Java Maven project from scratch using SpringBoot, followed by how to deploy the application to Docker. And then I also demonstrated how can you set up MySQL database server with automated initialization of a fresh database instance. As promised earlier, today I'll demonstrate how to set up RESTful Web API to display data from database using Hibernate ORM. We'll also see how to set up the local development environment and Docker deployment environment to quickly switch between the two. And this will help us to establish an efficient workflow for our project. Next up, we would set up our project to perform CRUD operations, again using Hibernate. And finally, we'll create our Web API endpoints, which can serve the requests from browser or from other client, and we would send the response back to the client in JSON format. So here in this example, we want to create two environments or profiles per se. Local profile for your local development and container profile for your Docker container. But you can create profiles for your different development environments like QA, UAT, staging, etc., as many as you please. So let's head back to our IDE. We want to start by defining our environments first. So let's go ahead and create a new file. We want to call our file application.properties. This is a standard name for application files of this type. We will also go ahead and we want to define more property files for different environments. The convention I'm using for myself is application-local.properties. It's just a convention I came up with. You can use your own, but as long as you follow it to the T. And we also want to create a container profile for our Docker deployment. And I'm going to create that file with the name application-container.properties. Okay, let's talk about the local configurations first. This application configuration file would be much simpler because we can simply hardcode the configurations. In the case of Docker though, we want to basically copy or read our configurations from the docker-compose file which we specified earlier. It would not make sense to basically duplicate those. So what we're going to do is we're going to go to our Docker container properties and tell SpringBoot framework to read from those files or parameters per se. Alright. The way we're going to determine or switch between the environments is something using spring.profiles.active command. This command would basically let us specify which environment we are planning to use. Here I'm saying container profile. And now my application would read from container profile. I can also say local. Well, this is the goal, but how to actually do it? For that, let's start from ground up. We're going to go ahead and add our dependencies. We're going to add a dependency to SpringBoot configuration processor, which would allow us to read the configurations. Now, next step is we need to create a new class in edu.godec.epidemics package. I like to call that class appconfig.bin, but you can call this class whatever you like to say. In this class, basically, we're going to go ahead and we want to insert the properties for the configurations we are using. So let me select few configurations real quick. I'm going to head back to config bin. to simply paste them, and I'm going to create my variables from them. Now I need to do a mapping that would define that which configuration value from my config file would map to which parameter. The way I can define that is I can simply say double quotes, dollar, curly braces, and my value. We also need to go ahead and determine the decorators we're going to use. So first decorator we're going to use is we want to tell Spring Framework that this is my component. Next up, we want to go ahead and tell Spring Framework that we also want to basically use it for our configuration properties. Finally, we need to tell Spring Framework what is the source of our properties. That can be done using property source. Here, I can basically say application.local application.properties if I had all my configurations stored in my application.properties, but that's not the case here. I have two environments to manage, so maybe I can say application-local.properties, and that would work only for local environment. If I want to do this, if I want to build this application for my Docker deployment, I would have to come here and manually change it to say container. So how can I make it dynamic so that I can just come up here and change local to container? The goal is to just change one word, and that should take care of all. That should help me switch between the environments. The way I can do that is I can specify that to use my values dynamically. I think my IDE is trying to read because it figured out my properties file. It injected those values, the effective values. Let me reopen, and yep, my changes did get saved. All right, so we're gonna go ahead. So don't worry about the green stuff you see. You can always hover over and you can see the actual value. Okay, I'm gonna go ahead and add my getters and setters, and I'd also go ahead and add an override for my toString method, just in the case if I want to go ahead and log my configurations. The way we can test it out is we can go ahead, go to our epidemics application. We can basically implement command line runner, and this guy has a method called run. We're going to use AutoWire. We have used this before, so basically let me tell you what it does. It's basically a dependency injection helper, and it comes from Spring Framework, right? So I can say, for example, add-config bin, and the dependency would be taken care by AutoWire decorator. Again, to test out that my configuration are effective, I can say add-config bin, and because I had created my getters and setters, I can probably just print, yeah, my DB URL. Let's go ahead and give it a spin. Let's make sure that we are pointing to local environment. Let's go ahead and say run. So if everything goes to the plan, then we just are going to print a URL, and it should be in our logs here in the console at the very end after my application is running. Okay, it looks like I already have something going on my port 8080. Let's go back to my Docker. I'm going to rebuild my application. Let's try it one more time. It looks like that I had another instance of debugger running somewhere. Okay, so now as we can see that my URL is being printed. To test it out, we're going to go ahead and change this to container, and we're going to say maven clean package docker build. So meanwhile that's building, let's go back to our IDE. When we say container, we are going to say in the end we want to print our DB URL, which is nothing but my hostname, my database, and port number. So this is what that makes up my URL. So if I go to my docker-compose file, it should have this guy as my host, this guy is my database, and this is my port number. Pretty standard. Going to see why. Oh, the build failed. You can go to documents, my folder. Okay, got my pom.xml here. We're gonna go ahead and build the package. One cool thing I like to show you guys is if I go to my directory here, target folder, here I would see all my resources. Let's open this file with package manager. It's just nothing but my archive file, and you guys can see that all my files are also being packed here. And this is my package, and it will also contain my class files. So that's what makes up a jar file. Okay, here the steps as expected that we define in our compose file are executed, and we have our build success. Let's go ahead and try to see if we can run docker-compose up. Again, I forgot to stop my IDE. Okay, I'll make sure that it's not being used. Okay. It's always a good practice to run docker-compose down followed by docker-compose up, just to make sure that we decompose or deconstruct any containers that might have been created along the way. So here in our case, a network that was created, and there was the container that were created as a part of the docker-compose up that we did earlier, and database server did came up the first time we did docker-compose up. So that would take care of everything. Another thing I'd like to call out right now, guys, and we're gonna come to that later in this episode, is I want you guys to notice that the DB instance and the web instance are running simultaneously, meaning the database is not still done being up, but my web server already started in parallel. We might have to take extra steps at the time when one server has a dependency on another. We can fix that pretty easily, and we'll see that later. Here is what I was looking for. Here is my log message. At the end, while my application started, in the run event got fired and got triggered, and it printed this guy, this string on my log message, which indeed is my Docker configuration. All right, we're gonna go ahead and stop this guy now. So I'm gonna hit Control-C to gracefully shut down. And I'm gonna do Docker compose down to bring down my environment for a clean start next time. Okay, so we achieved this objective. Now let's move towards the second part of our episode, Web API and Hibernate ORM. First, we need to add some Maven dependencies. Then we're gonna go ahead and set up the product structure. I would request you guys to pay a close attention to the product structure I'll be creating. I think that it would be very easy to bypass some of the pain along the way if you follow the structure that I'm using. So we are in our API, our project is stopped. I would head over to my pom.xml, and I would add dependency to Spring Starter JPA and MySQL connector. These are two standard dependencies that we would need. This guy would basically enable our connection to MySQL database, and this guy would let us use our Java Persistence API. That's what JPA stands for. So let's go to our edu.gadec.epidemics. Let's create 3 packages. First package is going to be DAO, Data Access Objects. Second package we want to create is called model. This would represent the entities in our database. And third package is called service. We would create our data access layer services here. We have this schema, and we're gonna go ahead and in our very simple database, we want to create a model, and we want to do CRUD operations for this table. As you can see, I have 4 columns or fields in this table, and that's what I want to use. I'd first go to my model and create a class in it. It's going to be a plain old Java object. I want to call it user. I'm going to create the fields for the columns I have in my table. Because ID is my primary key, I would basically decorate that with the @ID decorator. I would also add another decorator called generated value to automatically generate my values. And I can also determine strategies for that. I would say do that auto. I can use auto, identity sequence, any of the one that you can use that's appropriate. I'll go for the auto. Now I'm going to go ahead and create my constructors. I'll create a default constructor and parameterized constructor. I'll also go ahead and create my getters and setters. And finally, I would go and create my toString overload. Next up, I'll go ahead and create my user service. This guy, and I'll go to my data access object to create my repository. I want to create an interface, and I'll call it user repository. This user repository, we need to add a decorator for that to let Spring Framework know it's a repository by using a repository decorator. And we're going to go ahead and extend this from CRUD repository. CRUD stands for create, read, update, and delete. We're going to have to pass to, this is a template, so we're going to have to pass T and ID. T stands for table, and ID stands for the ID column data type. In our case, it's integer. So let's go ahead and pass our model. That's user. And we're going to pass integer. That's our data type. Believe it or not, we are done with repository now. Let's go back to model real quick. Let's also fix something real quick. We want to use entity decorator, and we want to go ahead and we're going to say that we want to use a table that's not user. We can say it's login table. As you can recall, my table actually is called login, not user, and I can change that and fix that real quick with this guy right here. Alright, we are now ready to go ahead and talk about our service now. This user service would require @service decorator first. Then we're going to use AutoWired to resolve the dependency for my user repository. And I would say this dot user repository equals user repository. I'd go ahead and create two methods. One would return me all the users, without any parameters required, and second would return me one particular user for a given ID. Okay, let me import my model and my list. I would now say list users equals new array list user, and now the user repository dot find all. And because I'm getting this method would return me iterable type of user, I need to map it to list type. So the way I'm going to do my casting is I would say users, and I would do add, and I would simply return the users. Okay, so my personal preference is to use the same name for the method for my service to what I have for my repository. It just makes my job easier, but that's just my personal preference. You can use whatever you prefer. We're gonna use next user repository dot find by ID. As you can see, it is returning me optional user type, so I'm gonna go ahead and play with it. So I'm gonna play along and optional user. Now that I have it, I'm gonna go ahead and make it return either user or null. If you guys are coming from C# or .NET, this is basically like nullable type. So I'm going to check if user is null or not. If it is not, I want to return user value, the actual user object, else I'll go ahead and return null. Alright, good so far. Now, I do not have MySQL database server installed locally on my computer that I'm demoing on, so I'm going to go ahead and use, guess what, a Docker container instead. We would wait for my MySQL Docker container to come up, but it should not be too bad. We're going to wait for the database to come up, and then we're going to try to see if we can connect. Okay, my database is now available. Or maybe not. Okay, it is. Okay, I want to see if I can query, and there we go. So let's head back and try to run our code. Locally. For that, I'm going to change back to local, and now say run my application. So in the front end, we are not going to see anything different, but if it works, it proves that everything we have worked so far is operational. Okay, so I see my log message here, which confirms that everything is perfect. Let me go back to my browser and just refresh the page. Okay, it's working. I'll go ahead and stop it. So that basically proves an important point, that it's working. And now I'm gonna go and do this. What I'm gonna do is, before we move on and be happy that we got it all wired up, we need to do two things. We need to verify that we can access the data, and we need to establish something that we're gonna talk about next. Basically, we're gonna now do a small experiment, and we want to go ahead and stop our MySQL database. So before moving on, let's see something real quick. I have my database server running here. I'm going to go ahead and go and stop my container. And I haven't deleted my container. So if I was to go back, I should not be able to connect. It stopped. Okay. Now, let's rerun the exact same application we ran a minute ago. I'm going to clear the logs. I'm going to run it again. We are expecting an error message. If you have, installed the database on your local MySQL database instance, you can follow along by temporarily stopping your MySQL service to make your database temporarily inaccessible. And the error. What's the error message? Let me make it bigger. Driver has not received the packets from the server. This is basically trying to connect to MySQL before firing it up. So we have basically established that Hibernate and Spring Framework basically have dependency on MySQL database before the application starts up. So we can do that. We can take care of this on our local development very easily by just checking if database is accessible before we hit that green play button. But what about Docker? For that, we need to do a small shell script to make sure that our web server does not start before the MySQL server is up and running. For that, let's start from ground up. So we're going to start from our Docker. In our Docker file, we basically need to say, here is where we basically are starting our application. If you remember my first episode, I said that this is entry point is nothing but just one command, and every time you have space, you put your word inside double quotes and you put a comma in between them. So this actually means that my command that I'm trying to run is actually looking like this. So this guy is nothing but exact same of this guy. And if you remove this two temporarily, it's nothing but I'm just running my jar file. And the parameters we removed are nothing, but they are telling that I'm just specifying that I want to use, or I just want to make sure that my active profile is container. This is just like double checking, putting a backup views on my build so that even if I forget sometimes to switch from local to container, this should, in theory, make sure that I am using container as my active profile. Okay. So I'm going to go ahead and add a shell script to check that my database server is up and running before I start my web server. Let me bring back my project window. I'm going to add the shell script here, and I'm going to just go ahead and call it wrapper.sh. And what I'm going to do here is I'm going to wait for my MySQL, and I'm going to say trying to connect to MySQL. And finally, when MySQL is done and I can connect, I'm going to break out of this loop, and I'm going to print the message connected to MySQL database, and then I'm going to start my web application. So you should see this log message, and then you should see your web application running by starting from that SpringBoot logo. So instead of calling our jar file, we want to call that shell file. But before we do that, we want to go ahead and we actually want to make sure that we copy that file. So we're going to make some small changes to our wrapper file, our Docker file like this. So in addition to jar file, we are also copying our shell file that we just created. We are making sure that it has permissions to execute, and we're going to execute that shell file. That shell file will hold the gates for our web application to run before my database server starts. All right, let's go ahead and try to do a brand fresh build. So I'm going to do a fresh build on my project. Maven clean package docker build. So we are pointing to our Docker container, and I'm seeing that my target folder is being populated with a new build. Another thing is that I'd like to point out is I already have things in place so that I can go ahead and I can basically copy my resources folder that are already in my resources folder. Okay, let's finish our build. Okay, and now let's say docker compose up. Now, as you can see, this is now effective. We are trying to see if we can connect to our database. And we are essentially constantly checking if the database is up and running. And here is the log message that we printed, trying to connect. And we're going to keep seeing this until the database server, MySQL server, is done booting up. So we just connected to our MySQL database. Okay, so as you can see, we established our objective by waiting for the web server to start before the database, after the database was up and running. For sanity, we can go ahead and refresh, and we see a new host controller. That's our new Docker ID, and it's the current time. Okay, so let's go ahead and stop it. The final step of this is to basically go ahead and add the REST controller. Let's do docker-compose down. After you're done, go back, and we're gonna basically delete. We're gonna keep this guy around, and we're gonna go ahead and add a new controller. It is nothing but simple Java file. We're gonna call it user API controller. We're gonna auto wire our user service. And what we want to do is we want to have two methods, public list user. I can say get, and I can say return my user service dot find all. So this guy is, we are expecting this guy to return all the users from the database. Second, we're gonna create a new stub for public user get, and this guy is gonna accept an ID, and it should return a specific user by the given ID. Now all that is good, but we need to do two things. We need to first go ahead and add the mapping. So just like last time, we're going to go ahead and say get mapping. That get is basically nothing but it represents HTTP get verb. You can also do, for example, put mapping or delete mapping. But because we want to do get, because we want to get the resource from database, we're going to say get mapping, and I want to map this to /API/user. So I personally prefer to distinguish all my MVC routes from my API routes by a prefix API. I think it's very clear, and I think it's very simple to, and it's very intuitive. For my second guy, I'm going to go ahead and specify ID in my curly braces, declaring that this is an optional parameter. If I don't pass it, this method would be called, and it would return me everything. But if I pass ID like /API/user/5, I would basically get a particular user from the database with ID 5 if it exists. Else I would get null. So to reiterate, this is how I'm going to call this guy, and this would return all the users from the database, and this guy would be called with this guy and returns a user with given ID from the database. Okay. Now that we have everything in place, we want to do one last thing, and that would be decorator. Now let's go ahead and start our container. Because we made the code changes, we're gonna have to go ahead and rebuild our Maven package. Alright, we are saying that our wrapper.sh and all the files, all the steps are being executed as expected. We also copied our wrapper file here. Now let's go ahead and see if we can do docker-compose up. here, just for something extra. Here, the MySQL server and Docker are logging that they executed our schema.sql and data.sql, which we talked about earlier in the previous episode. Okay, now my Spring server is up and running. Alright, I have the confirmation that it's pointing to the correct database URL. I'm going to go ahead and try to refresh. Okay, so far good. I'm going to say API/user, and voila, I see my JSON here. It returns all the data I already had in the database, and here Firefox is basically just trying to help me to tidy up the JSON format. I can also go ahead and say /1, and we got an error message. Optional parameter integer ID is present but cannot be translated into null value due to being declared as a primitive type. The way we can fix this is, let's first stop our container. What we did not do is we declared ID as our path variable, but we forgot to add our path variable. This decorator would basically map the value in the path to this particular ID. So Spring Framework noticed that there is something, but that did not get mapped here, so this method could not be called. We're going to wait for Maven to complete the build, and then we're going to instantly run docker-compose up. This time I'm going to run it in the background mode. Okay. So I started my container, and my docker-compose should be up and running, and it started my databases. I'm going to say docker logs epidemics web_web1, and I'm going to say that I want to follow the logs. It is going to do nothing but simply stream my logs. Okay, let's try again, and we fixed it. Now we are getting the user by ID. That concludes the demo. Thank you guys. See you guys in the next episode.